Hello and welcome back. My name is Corey and you're my rubber ducks for the evening, and this is the series of episodes where we are creating Tang, a custom programming language, and we are writing this programming language from scratch using our C++ skills and some basic tools like Flex, Bison, Google Test, ICU. Vim is our editor of choice, and just in a terminal window. And I don't know what else to say about it other than you don't see a lot of that on YouTube. This is 100% live coding. That means nothing up my sleeves. I don't have anything pre-prepared. This is episode number, what is this? Episode number 72. And we are in the process of adding a library functionality into our program. And the goal is if you have a basic interpreter, a basic instance of the Tang machine, dare I say that, and why do I call it that? Because it can take either a script or a template, compile it into a program that is bytecode and associated data, and then it can take that program and execute it more than once, right, by providing different context data to it. And that's fine, but what we want to do now is, and what we're trying to do, is to have libraries of functionality, of additional functionality. So for example, to have a math library, and maybe it will have the trigonometric functions in there, or other math tools. Yeah. But the problem is, how do we get our program to store that? And there's a couple things that I'm thinking through right now. One of them is the fact that I forgot to put my phone on silent, and I don't want it to go off. There we go. It's on silent now. One of the things that we thought about, or that I'm thinking about, is just like when we declare a function, that needs to propagate into the child scopes. Okay, so that's something I got to worry about. And, well, how does it do that? Yeah, I'm just going to stop there so I can think. So, yeah, sorry, I started thinking about another. I've been thinking through several different solutions and ways that we can solve parts of this. And I don't have a complete solution in my head, which is hard because I've not written this part before. I've said this in other videos. I've written a programming language 2 times in preparation for trying to record this series. And I've done it different ways on different parts. And now we are to the far reaches of the programming language. That by far reaches, I mean we're doing implementing features that I have not implemented before. So I've got like a page of notes of drawing out things that I'm thinking of I might want to do or not do, and how we can represent that. So let's just open this. Well, for the moment, let's make clean and then make test watch, just so that we know that we've got a fresh build. And on the left hand side, we're going to open our test file and see kind of what was the very first test that isn't working at the moment, but it's the ability to be able to say use math and then print math.absolute value of 3.5. So then we've got a couple questions. What happens when we say use math? And we know that math is an identifier that should be some sort of library name. And so when we say math, we need to have some sort of object that that represents the math library. Okay, and yes, this test is failing because it was commented out and because we're not ready to run it yet. So here's our the latest documentation. If we look at our classes, we have a computed expression library that we added. And so in general, math should return a computed expression library. And then if I say math.abs, so .abs needs to return something. So if I ask this computed expression library for something in .abs, or excuse me, something with that identifier .abs, ooh. Sorry, just again started thinking about this. I might be able to. I've been going back and forth about whether or not I can reuse the functionality that we wrote for the generic methods, and I don't think so, because the purpose of a library is so that we don't have to instantiate everything unless we need to. And yes, that is okay. So as it is currently, this is worth looking up. How did I write this? You say, Corey, I don't even know what you're talking about. I know you don't. Because what I'm wanting to see is the source program execute. Okay? And when period, period. There we go. What we do is we call this, and if the result is a computed expression native bound function, so whenever we call the dunder period, and what is happening with dunder period? Well, that is source computed expression. That's happening right here. It's this function right here. So what it says is okay, so the computed expression string is the name of the thing that we're looking for. So it's giving it a string, and then we say get object methods, and object methods are a list of all of the type IDs followed by what is it? Oh, it's a pair. So the point is that it has a function that, edit macros, include macros. It specifically returns that. And in fact, if we one more time edit the source for Tang base, and right here the get object methods, it's a type index, so mapping a type to a native bound function map. What is a native bound function map? That's this right here, and that is so for each function, for each type, sorry, again, just thinking. For each type, there's a map that is the name of the whatever it is, the name of the method, and then a pair, which is the number of arguments that it takes, and then a native bound function. So this the object methods is only native bound functions. And the problem is our library is not native bound functions. But what I'm wondering is, so we've got the period is, so by default we're looking at the native bound functions, but if we do this with the library, we could look at something other than the native bound functions. We could call get something. And did we already write that is the next question. So the source ComputedExpression library? So no, we don't. Okay. So we're going to do that then. We're going to have a dunder period. Yeah. Oh, okay, that's why. Somehow I didn't get the... Okay. So right now this has all of the same stuff. And instead of object methods, we're going to have a different... I was going to look at the log file and see what was all in the commit. Because, quite frankly, I don't, like I said, I don't have this pre-planned. And so that means I'm flying by the seat of my pants here. And it's like, well, also I've slept since the last programming thing, so I've kind of forgotten some of the stuff that we did. But I know that we want something other than the object method. So let's back up just a little bit, and in the tangbase.cpp, we've got get object methods and get libraries. Okay, so the libraries is I think this is going to be very similar to the object methods. Okay, so in that case, I think I want this to also be a type index. And now it's not going to like some stuff. That's fine. Don't know why. I mean, I know why it's doing that. I just haven't fixed it. I don't know why I haven't fixed it. A type index, okay. Now, what is libraries? Libraries is not that. This is tangbase.cpp. Yeah, that's in B5. Everything's out of order right now. Oh, libraries itself. needs Now, I'm calling this native function map, but something tells me that's wrong. Let's look at macros. So native function map So it's not a native function map. Okay. So we need to make a distinction. What all do we have? I mean, if we think about the types of functions that we have compiled functions, right? That is, everything's in bytecode. We've got native we've got native library functions. No. I mean, we've got compiled functions, we've got bound native functions, we've got native functions, and all of those take a number of computed expressions as the arguments, and this is not the case. We want a library function. Yes, that's what we want. So, I'm just looking at something before we get it. So we've got get libraries. I'm going to just call these library function map. And now we need to edit number 7. Oh, no, we're already in number 7. 5. Okay, and of course it doesn't know what library function map is, and so we need to edit 4. Is it the case that we don't even need native function map, that we just need library function map? And this doesn't need to be a standard pair because it's only going to take the context. Okay. See if this compiles. It may be that I didn't need that native function map at all. We're about to find out. And if I get a segmentation fault, that'll mean that I didn't recompile something I needed to compile. Okay, so ComputedExpression library. .cpp, .hpp, so include ComputedExpression library. But I don't think we need this anymore. Because it's going to use the library function map, which is tied to the base class. So yeah, we don't need this anymore. We don't need any private stuff there. We will need the but I don't remember what's in it, so six and then 8. Const garbage collected ampersand. Well, you know what? Here. Okay. It's going the wrong way. On the wrong window. There we go. So when we make it, I don't think we need anything at the moment. Oh, the library. The make copy. And then we're going to need to pound include something up here. Is it type info? Oh, ComputedExpression string, need that. And I'm not going to use a ComputedExpression native bound function. But for right now. Oh, that's why. Missing this line. Need ComputedExpression error. All right, so a lot of moving around stuff. Let's see. Native function. So I guess we do need the native function thing. Macros. No. Is that right? Find out soon enough. Let that be a lesson to you. Don't remove stuff willy-nilly. And by the way, yes, I do know that we can make this compile faster. It's just I don't want it to be compiling 3 things and getting error messages on 3 things simultaneously. Oh, okay, because it's name literal, program execute. .263. So this is in the library. Get libraries. Okay. So this is a different problem. We've got a chicken and the egg situation here, in which case I was trying to have when I say math, I need to know what type or how to create I need to know that that is a computed expression library. Yeah. And which one? Because we're going to have a one that represents the math library. So computed expression library math. So this isn't necessarily wrong, but I don't like, so we need a distinction between libraries and the library methods. Or, yeah, because library methods aren't the same as a regular method, and that's an important distinction. So, okay, now that we have that clear in our heads, you said that wasn't clear before? Nope, not in the least. So what do we need? We've got available libraries, and we're going to copy this because now we actually need two different things. So we've got store the available libraries and store the available library methods. Maybe attributes is better. Yes. Okay, so we've got library attributes, and I think that we need a library attributes function map and then a library, and this will be a string and so I'm in number 7 and I need to go to macros. So what do I have that I can use? A library function. Yes, that's what we'll use. A library function. Will that work? Yes, because I need something that will create the garbage collected value, and I don't want to create any garbage collected values before they're needed. Yes, okay. So we will use a library function. So this is going to be a string to a library function called libraries, and then for each type, library attributes function map. Wait a second. Is the library attributes function map a string to... Okay. So that's all I need, library function map. Library function map. Okay, so we can say get libraries and then this will be get library. Oh, come on. Attributes. Get library attributes, and get libraries will return a library function map. Okay. Now Tang base .cpp is 5. We've got get libraries. get library attributes. And then, you know, I think I had, well, that didn't work. Okay. Oh, yeah. 134. Okay, that's fine. I can work with this. Just trying to get it to compile. All right, so again, to back up, so our Tang base, it's going to have, first of all, if I ask for math, it's going to ask for that out of libraries. And that should return a function that I can execute that will in turn provide something. A computed expression of some sort. And now that may be a computed expression library, or something that is a derivative of a computed expression library, which is the goal, yes. And then for those computed expression libraries, they will have their own attributes map, just like the normal methods have theirs. So we're not mixing them. And again, it's important to understand why. Normal methods are always functions, right? If you say string.length, it is parentheses, always, always, always. It's a function that must be executed. It is a bound function specifically. And so object methods just, yeah, it returns bound, native bound functions. However, library attributes will be a library function that just gets the context and executes. And from there, it can, well, do a lot of stuff, I suppose, but it can return whatever kind of, it can return a function that, a native function, a string, an integer. You know, you could have a something that, because it will get the context, it could store something in the context, and you could have something like, you know, math dot monotonically increasing, not a function, just monotonically increasing, and every time you access it, it increments by 1 and gives you the next number larger. You can do all that kind of magic stuff, and because it is in a function, I mean, because it's part of a library, it'll just work. So yeah, that's what we're doing. Okay, so that's why we need two different things. So now we've got libraries and library attributes. Now, so our program execute, this is in the, when we're trying to execute op library, now it's getting the libraries and it needs to know what to do. So we need to go into the program execute and right here. So what all do we have? Libraries, this line right here requires a string. So that's why we are getting the name converted, whatever the name is, and getting it as a literal, and we're saying, does libraries count exist in there? If so, then we you know what? We don't make anything here. We're saying if there's an entry there, then all that we need to do is call that, whoops, with context. Is that all? Oh, and 638. 638, where are we? So that's an opcode library. Did I mess up something? Oh, for the native function. So I have messed up whatever get function returns. That's a problem. So let me look at macros again. And oh, native function. It's you know what? Easiest way is to say get diff and look for what is different in macros. Oh, of course. Well, wait. Native function vector, and it needs the context. That's what I'm missing. Okay. And of course, since we changed something in macros, it's got to recompile everything. In fact, make clean and then it's like, why didn't it keep going? I didn't finish the command. Okay. Multiple definition of computed expression period. And I know where that is because and that is in computed expression library B6. There we go. This should be computed expression library. Okay, it's compiling now, but we're not done. So this is, we're going to change object methods for library attributes. What on earth did I just do? Object methods okay, and this is going to be get library attributes. attributes is equal to that. We're getting the name of the string, and this needs to be attributes.count. Attributes there, and we're going to execute. You know what? And I expected this to be a pair. It's no longer a pair. It's just a function to execute. So we're going to return fn. Oh. Do I have a computed expression for this? Computed expression library function? No, I don't. Guess what we're about to make? So why? Because we don't have a context, and we have to give this a context. So we're going to have to, when we execute the period thing, if it is a library function, then we need to execute it. Okay, so now we don't have this computed expression library function, but we also don't need the bound function. Should it be called? We've got native. I don't like it because namespace wise, I think everything, so like library, computed expression, library, math. Computed expression library, date. Function to me seems like namespace wise it should be there. So I think we're going to call this native library function. Yeah, we're going to have to, just for consistency in naming. And now it's going to say, hey, I don't know where this is. And I'm going to say, of course you don't, because we haven't told you where it is yet. But we're about to make it. So we're going to copy, start off with our includes, and we'll just do computed expression native function, and we will call this include computed expression native library function.hpp, and we will copy our source for computed expression native function to be source computed expression native library function.hpp. And as always, guess what we need to add? We need to, in our make file, computed expression oh, there it is. Native library function. Okay. And now we need to edit those files. So them are include ComputedExpression native library function and our source in source ComputedExpression native library function. And believe it or not, this is taking it's taking shape now. So let's do %s and native function needs to become native library function, and we'll do the same thing for native function will become native library function. All right, and a native function that is executed by a library attributes. It's not really a workaround. The purpose of this function is to be able to construct a library or the library attributes as needed at runtime. Okay. I don't need any of that. We get the native function. How about the library function? The library function. Okay, and we don't need the argc. I think it's just a library function. Yep, library function. So library function, and we don't need the argc. Okay. Dump, make copy equal? Maybe, I don't know. We don't need the argc part. Don't need this one. The library function to be executed. All right, And now, over here, we're going to switch out native function with native. Okay. Just a library function. Library function and change this name. Maybe I could have done it globally, but equal native library function, a library function. That should work. Get function return yeah, we broke something. I'm like, what did I do? Oh, this is called dot move source ComputedExpression native library function .hpp to, one moment. I had to sneeze and it was not graceful. So I just paused it really quickly. Source ComputedExpression native library function .cpp. Oops. Oh, hey, it's compiling. That's always suspicious. But I think we are at a safe place that we could do a commit, and then I want to get the math one working. Yeah, let's try that. So, what all do we do with the make file? Oh, I've got to figure out how to break that apart. Okay. Computed expression library is nothing but something that represents something else. Okay. It could have extra functionality, but in general, anything that inherits from this computed expression library will, when you call the dunder period on it, will look to the library attributes stuff instead of that. Yeah, okay. Library function, blah, blah, blah. Let's see. So all of these look good except test. I don't want to include test. That means we get to add. So git add include computed expression native library function source computed expression native library. So now git add make file include that include macros include Tang base, our source source program execute and source Tang base. Now the only difference is that, and I don't want to include it. So what was I saying? Second step, add the use keyword and prepare for library objects on the Tang. Okay, so this is going to be the third step. Git commit. Third step, add registries and CE types for libraries and library functions. Library function. Okay, that's fine. Now, the problem is when we call dot period, and this is in the execute. So our source program execute. And if I go to period, I already know that this is going to be an issue. What we do is we call the period, and we say if it's a native bound function, then set the target. However, I think we also need to do if type ID of temp is equal to the type ID of computed expression native library function. Then we need to execute it. Then we need to say auto no, we can just reassign. Temp is equal to temp. How about static cast as a computed expression native library function ampersand of tmp dot get function context. That should work. So what we're doing again is, I need to pound include computed expression native library function. So we're on line 428. Native library function and 428. And what this is doing is, first it says, okay, when we call the period, it may return a computed expression native library function. If it does, execute it immediately. In fact, I think the better thing would be to say while it is that, keep on executing it. The point is we should, yeah. All right. So then, whatever else is needing to do. But I think that should work. So I'm going to put a comment here that says resolve any requests. Not be done earlier because under period does not have access to the context object. So we clean that up now. Okay, I'm also going to add a comment here. Say set the target of a native bound function. the target LHS you know what? I'll just say it here. This could not be done earlier because Dunder period does not have access to the target object LHS. So we clean up that part now, and so we clean up that part now. That's not a split infinitive, but I don't, anyway, whatever. Onto the stack. There we go. There. There. Blank line. And now, again, the test won't pass, but this, I think everything is in place. All right, now, what do we need? Oh yeah. So I'm not going to add the commit, but I do want to at least go ahead and take care of this. So this is in source program execute, and the message is going to be clean up the return of a CE native CE ComputedExpression native library function by Dunder period. During program execution. That's a lot. That's a mouthful, but okay. And now, what do we need to do? We need to make one. We need a math. So, if we look at our source for Tang base, our object methods, we do a type index of that, and we call ComputedExpression get methods. ComputedExpression get methods. I think, so that's on object methods. And if we look at our includes for Tang base, I need to delete that file. We need to do the same thing with libraries and library attributes. Yeah, we do. So it's libraries and then library attributes. All right, that should compile even though I'm not doing anything. And we need to copy our include ComputedExpression library, and it will be include ComputedExpression library math.hpp. Copy our source for ComputedExpression library, source ComputedExpression library math.cpp. Okay. Our make file. Add that, so library math. And this is now going to be library math. Library math. Okay. Oh, now I need to edit these. So edit our include ComputedExpression library math, and we need to %s this and substitute library for math. Okay. And do the same thing for library math, and it is going to inherit from ComputedExpression library. Okay. For mathematical operations. Oh, I guess that needs to go away. If I edit the include for ComputedExpression library, yeah, that needs to go away. All right. I'll keep the dump, the make copy. The period is going to inherit. Does make copy even do anything anymore? Edit the source of ComputedExpression library. I'll keep it just for right now. Although it's kind of ugly, but all right. What if the dump returned the type information by default, and then I don't have to have it? And I don't know of a way of making a copy of myself yet. I'll leave it at this for right now. And now library is becoming library math. And this is, you know what? Library math. Library function. There we go. Make a copy. That's fine. The dunder period goes away. For the moment, okay, so now what I think is if I edit the source for Tang base, what are the libraries? The first one is going to be math. And what do I do with it? I'm going to edit just for the moment source for ComputedExpression string, because we're going to look at its get methods. There we go. And you see what all this is? Yeah. So this is a lambda, and it takes a context. And it returns a garbage collected value that is ComputedExpression library math. Maybe I don't need that at all. Wait, no, because the library, it could do a lot of things. Okay, for right now, because this could become a really nice small macro. There. So when I ask for math, I should get this ComputedExpression library math, right? That is, I get this function, and then library attributes, on the other hand, would be ComputedExpression library math. Okay. All right. So, ComputedExpression library math. Get library attributes. Yeah. Now, of course, library math does not have a get library attributes, which we're about to do, and that may be what this is griping about, or it may not be. But it probably is. All right. Let's do that. So, I'm going to steal the strings 1 and now go into ComputedExpression library math. Uh-oh. On this side, so in not include source ComputedExpression library.cpp, you see I had all of this stuff and I deleted it, and the problem is I should not have. So I'm going into source and seeing what's the ComputedExpression native library. Wait, do I not have a native library math? Oh wait, library math.cpp. I do. ComputedExpression library math.cpp. Yeah. rm ComputedExpression library math.cpp. And now copy ComputedExpression library to ComputedExpression library math.cpp. There we go. And now over here, undo my changes that I did to library. Okay. Just back up there. Make test. It's going to complain, but I know that. So now let's go back into this. Edit the source for ComputedExpression library math. There we go. And like, why wasn't it? Oh, because I had 3 nested. All right. So this is not going to it should not return that. It should return a include macros library function map. Yes. Library function map. Okay. Library function map, ComputedExpression library math, get library attributes. Length is no longer that, and in fact all that it needs is context, which may be unused. All right, and we're going to return and that is right, ABS. A ComputedExpression pull up my documentation. ComputedExpression native function. That's what we want. That takes a function and argc. So native function that takes a native function and argc. The argc is 0. And that'll be the end of that. All right, and what goes in here? What is a native function? A vector of garbage collected, and ampersand args context ampersand context, and that will be maybe unused. And now we can put our function code in it. And computed expression. I don't need string anymore, but I do need integer and float. So error, integer, and float. So the type ID of args.at0 is equal to computed expression integer Don't know why it's trying to jump all the way over. Because if it's an integer, it's already been truncated. And wait, am I doing absolute value? Or am I doing round? Which one am I doing? Absolute value. Okay. Do I want to do the absolute value? Because that's obviously... I think I want to do floor. Yeah. Floor. Sorry about this. Okay, those are all changed to floor. And now V7. This is no longer ABS, this is floor. And you know what? I'm just curious because C++ floor. No, just give me a find a reference one. This will work. Rounds x downward, returning the largest. Okay, so a negative 2.3 should be a 3, or a negative 3. Yep, okay. That's what I expected. Yeah, that should work. And I just closed that, or I didn't close it, but is that, if I just call floor, is that part of, it's part of CMath. Okay, fine. I may have to pound include it. All right, so if it's a float, then I want to return garbage collected, make computed expression integer of a oh, that's fine. Floor of something. And we'll do this something in just a moment. Those are if I do this, I was afraid of that. See, those are putting in tabs. You know what? I know, I just... Is it because I'm... Oh, make file, that's why. So, computed expression math. Not math. Computed expression library math. Besides, that was not math, that was math, but oh well. Still doesn't like that. But if I do this here, oh, that's why. It's ugly, I know. But make computed expression error, where we give it an error I'd rather have a more general error, like maybe unknown argument type. But we still have to get, how do we get to the floor? Okay, so if we say a static cast as a computed expression float of star args.at0 dot, and now go back to our documentation, because computed expression float there. Do we have a get val? I think it's private, so yeah, get value. Get value. Oh, okay. Library function map. Get library attributes. So, question is, edit the includes for computed expression library math. Hey, look, I didn't declare it. That would be why. Return the functions for this library. Returns and I think that this would be better to say construct sure. What? Line 10. Let's go back up and reread that error message. So it's saying that in file included from that in library math.h, we expected a semicolon after the class definition on line 32. We have that. Oh, that would be why. Mere technicality. All right, back to normal syntax errors. I can deal with these. So it's going to be saying for floor, garbage collected make ComputedExpression native function. And I'm just going to go ahead and open this garbage collected native function. ComputedExpression native function, yeah. Yep. What does its construct? What is its constructor? It takes a native function and then a size t. Expected primary expression before the token on line 30. What? Forgot the type ID. All right. No matching function for call to float. What? Let's see. Oh, of course, ComputedExpression native function was not declared in the scope. Let's fix that. Getting a little better. Okay, it's still not liking this. So what am I doing wrong? Okay. No matching function for call to Tang ComputedExpression float, and we're trying to static cast it. ComputedExpression float given a ComputedExpression ampersand. I believe this is supposed to be. Where's that static cast? Ampersand. All right, and narrowing of from float to integer t on line 35. Oh, there's a lot of things here. Oh, yeah. Well, okay, so float, we actually saw it. I don't think I have that documentation page. No, I don't. But floor returns a double. So, and that's just, it's telling me, hey, it's a double and integer requires an int. So, that's what I was saying. It's narrowing. It didn't like that. So line number 39 as well. What's on 39? Wait, what? Okay, let's read the entire error message. In instantiating a make with ComputedExpression native function, args is equal to the lambda and an int from an int to a size t. So library function map, I just want to look at this would be fixed if I just change that 0 to cast it to a size t. But I don't think I did that. Edit the source for ComputedExpression string. Yeah, I didn't do it here. Oh, I don't want to close it anyway. Let's look at the macros again. Okay, so I'm just thinking I shouldn't. There's got to be a better way. I mean, I could just change that to an int. ComputedExpression native function. I just want to look at this one's include ComputedExpression native function. See, and it takes a size t for its argc. What do I do for the native bound function? Include ComputedExpression native bound function. It takes a size t. Why are they in a different order? I don't know. But it's not complaining about this 0. And yet it is complaining about mine. This one. At least that's what I think it is. If I compile, it's probably. So maybe it's something else. Maybe that's a symptom of something else. Oh, is this a static? Should it be static? Let's look at the string one, which is 3. Get methods. And the get methods. Yep, it is declared static. Okay. In that case, still not liking it. We're closer. We're so close right now, and I'm 2 hours in. I was like, oh, we'll get this, and then we'll stop the recording. But, well, of course, you know, we'll make sure our test is passing. But so we don't have this, and maybe that's why it's giving me the error. Okay. Map of a string to, okay, so there, that's what I wanted. So we've got two things. Native bound function. It's a library function map that's there. And yeah, that library function. Okay. And if we look at Tang base, library function map, type index, library function map. What is a library function map? Wait. The library function map is a map of a string to a library function, and a library function is garbage collected, and it takes a context. Okay. So what does it not like about this? We're looking right there. No matching function for call to a map with a string to a garbage collector, and this is a lambda, returns a garbage collected, context ampersand. Because these have to be pairs. That's why. That is why. Edit source tangbase.cpp. So for each one of these, you have to do them as a pair. There. Should like that a lot more. It's compiling at least. So, we think, we've not tested any of this, but first I'm just taking a very quick little cursory look through to make sure that everything is making sense. All right. First, we're going to dump the bytecode, see what we get. And so it's null val. That should be our holding place for the word math. And then math as a string, floor as a string, peak 1, that's math, call library on it, and we're popping that immediately. We didn't poke that into a place. We should have. Okay. The next one, 3.5, though, that would be this peak 0, which should be math. Is this right? Peak 1, library. Okay, 3.5, peak 0, peak 2, which is floor, period, math.floor, call function with one operand, and then print. Okay, so the only problem is we're missing the storing after we do the library. So that's going to be in our AST node. Edit the source for our AST node. Which one is this? Is this library? I think it is. So the compile peak So how do we do this with strings? I'm glad you asked. We're going to go into that. For the source for AST node string, we've got to compile literal, but on the regular compile, isn't that what we do, though? No, this is everywhere where we see we peak oh, okay. Okay, so what are we going to do? We're going to first load the library onto the stack, and then save the library into its proper, well, I was going to say its proper, yeah, proper stack location. Okay, so we're going to, this will be poke and we've got, so it's not, we've got name and what? The alias is name. So, okay. So we've got name and and this dot name. So we've got shadowing here, and it didn't give me a warning. Okay, so this is going to be library name. Okay, so we're going to need to kind of change how this is working. Because basically, ultimately, we want, math as M. M is the alias that we want to reference it under. And that should be like, in this case over here, position that. But we still have to load math. We have to call math and then library. Yeah, math and then library. Oh, all right. So we've got the library name, that is this. And then we're saying strings.count library name dot count this arrow name true. So there's going to be both of them. We were not looking at this earlier. There. So this arrow name and add identifier signed wait, add string. So we've got both of these strings. Ooh, 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 ooh. No, no, no. This is wrong. No, wait, wait, wait. Name is the... I'm about to change this because name is too confusing. AST node library. We're going to call this alias. An alias alias used to access the within the script. Okay. And now we no longer have name, we will have alias. Alias, okay, that's fine. AST node, wait, this is AST node string. There we go. So we no longer have name, we have alias. Okay, we're passing that in. Don't know why we didn't do this sooner. We're adding an identifier for the alias. In fact, we can't, this can't be the case. So we don't need to do the is assignment check. Add the alias. As an identifier. Okay. As strings, they be used by the bytecode to load the That's fine. Do we need the alias as a string? No, because it's an identifier. All right. So now the library name is the expression.name. Okay, that's fine. If the library is in the strings and now the string, this is wrong now, but I'm going to edit the source for AST node identifier. And what does it use? It uses identifier.at. So we're going back and forth now between 5 and 2. So we've got strings and identifier. Okay. There we go. So our string, the library name, yeah, we have to use the true. But the identifier is just a bare string, and we use it internally. It never actually makes it out into the program. That's fine. So we peek, we we don't even need to do this. We can just say identifiers. Okay. Dot size, that's fine. And then call library. And now save the library into its proper position on the stack. How do we do that? We poke and B2. There we go. Identifier.at, this arrow alias. Is that right? Yes. And why up here do we have to do strings plus identifiers? Because identifiers come first and then the string, so we have to bounce past all the identifiers to get to the string. Identifiers, not identifier. Oh yeah, right here. It's not a function to call, it's already the thing. Now we've got errors. Unused parameter preprocessed state. Fine. Line 38. Oh, it's not name anymore. It is alias. Name is not declared in the scope on line 41. And this is library name. All right, so let's see what it's doing. Null val, math, floor, peek at 1, which is math, library, poke it into 0, pop. Float 3.5, peek 0, that's math, peek 2, which is floor, period, call func 1, print. So, what are we getting when we... So at the period, that should be the library period. ASC node library. No, this not ASC node. Edit the source ComputedExpression library. And we will say, just want to know first, sanity check, are we here? Yes, sanity check, we made it to the right place. So, are we at the innermost? We are. We make it all the way there. Are we executing it? That would be source program. No, wait. So when we call period, no, it would be program execute. See if we're in here. We are in there. See what this gives us. It's giving us a native function. This is all good stuff. So, let's open the source for our ComputedExpression library math. Floor. The whole here thing. Because nothing else is printing out here. We're not getting there. Oh. Oh. Do you know what the problem is? Program execute. Let's look at call func. If the type ID is ComputedExpression compiled function, if it is ComputedExpression bound function, native function, wait, it should be there. Earlier, when we ran it, it said yeah, native function. Native function. And isn't that what the math is outputting? It's returning a garbage collected computed expression native function. I'm going to I think I need to also add a C out here so I know where I am. Okay, so starting, it even gets to here. So what's the result? Did I mess up in the math? Did I say it? Yeah, look at this. Floor requires 1, and I said 0. I bet I can remove that now. Watch it be that. Which means it's been working for the last 15 minutes. It's passed. All right. This is outstanding news. That means we have a library function. Yeah. Yeah, that's what this means. Okay. I need to delete the C out there. And it's working. I just want to see if this next one will work. Nope. It's not, but you know what? Let's see what the code looks like, shall we? I want to know if it's exactly the same. It should be exactly this. I should have two couts. Did it stop? 2255. It stopped there. Oh, it's not compiling. Otherwise, we would have some bytecode. That's what the problem is. So our use as is not compiling. And I bet you if we looked at, I don't want to delve into it, but if I work for... Yeah, use identifier. We don't have a use as. What's funny is I think I can add it really quickly. But you know what? First, on the right-hand side, do that. On the left-hand side, see what our differences are. We've added a math library with a floor. All right. Just waiting for everything to finish up. Everything is still testing, is passing. Add math library with floor function. All right. Now, I said, I betcha I can do this really fast. So here's what we're going to do. Right here, I'm just going to uncomment it, and in Bison, looking for the use right there. Two, three. Four. Oh, I didn't have that. And I bet now both will pass. It's passing. Yeah. And so the reason is, and if you don't believe me, we can take this, and so if I were to say math.floor, it wouldn't know what that is because it's not storing it under the word math, it's storing it under M. Oh, wow, why did it why is it recompiling everything? I'm not sure what happened, what changed that it thought it needed to, but yeah, it failed. But if I change it back to M, it passes. Yep. And that's what I wanted to see. Okay. So we've got our use, our use as, and excuse me, we could probably check to make sure, but that is a problem for future core to handle. Right now, this recording is almost 3 hours, so we are get status, get diff. What did I? Oh, did I not include the math library? Oops. Okay, and you know what? Okay, I'm sorry. I'm just going to go from here. Bum, 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 bum. All right, make docs PDF. And as always on the left-hand side, just get all sorts of stuff going on at the same time. My computer sounds like a 747 trying to take off. All tests are passing. Yeah. -M. Update docs for episode, I don't know. Episode 72. There we go. All right, and what else? It's pushed. All right, and where are we? 9,881 lines and 3,654 comments. And of course, we updated our documentation. So if we were to, well, I'll just check out our classes. We'll see that we have, for example, ComputedExpression library math. And we might have a faster way of generating these. I'll see about that. I think that there would be. See, it's got all this stuff, and it just seems almost wasteful. But to me, there's a good reason to do it this way, but I'm going to mull it over. But for right now, what I care about is the fact that this is working, and I'm very, very happy for that. And sorry, brain just stopped working. But checking on something. Yeah. So where does this put us? Vim source, not source, include tang.hpp. We've got a use syntax for importing that. We don't have anything dealing with the versioning. We've got a library thing, but we don't have... this can be started. Let's see. Anything else? Nope, that's it. Okay, that's pushed even though it's not part of the tag. It's not a code change, so I'm okay with that. And so where does this put us? Well, we still have some more work to do on the library. We can't say use math.floor as floor. You know, and I think that that's probably the next thing, is to be able to drill down into a library and set an assignment for that. And really, you know what? That's really what it is. It's really just an assignment. The use statement is like an assignment operator, giving a name. And I wish I'd thought of that or realized that a long time ago, because that would have made it all so much easier. In fact, I think it simplifies the way I was thinking about how we're going to have to do the drill down. So, okay. So the use statement is just a fancy assignment operator that specifically calls out a library as its starting point. And when we call the dot operator on anything, then it will say, and if this is that special kind of function, resolve it to get a computed expression, the right kind of computed expression. So, yeah. Wow, okay, this may be more straightforward than I thought. Still going to need a little bit of work, but it's pretty much going to fall into place. And, well, that's a good thing. I have rambled on for long enough. This went about an hour longer than I was hoping it would. But I'm actually really happy with where we are. Our approach to it, I think, is we have a good approach. So, as always, thank you for joining me. And... well, I don't know if I should ever say I hope it's entertaining, I hope you enjoyed it, whatever. If it were me, I watch this kind of stuff. So, because I always pick up stuff. So I hope it's been beneficial to you in whatever capacity that you are ingesting this material. Thank you, and have a great day.